Hello together and a very warm welcome to our first digital coffee break in 2020. I hope you have all a warm coffee and so we can start for today. We have in our session today Manuel Rüter from TE Connectivity in our meeting. And hello Manuel, I hope you have also already a coffee and enjoy the day. Yeah.
Sure, Matthias, sure.
Okay, then enjoy the coffee and I will give some general information and then we jump in our topic of today. First of all, I want to give you some information also about the single pair industrial partner network. So we are now a group of around 52 members all over the world, and our vision and our work we do together is to build together the single pair Ethernet ecosystem. That means all the components you need to build up devices, to build up single pair Ethernet systems and so on. And in our last sessions, we discussed already a lot about different aspects of single pair Ethernet. And the topic of today is also the topic how to bring not only data, also to bring power to this different single pair Ethernet devices. As we have discussed also in some of the meetings, single pair Ethernet is a nice technology to bring data and also power to field devices. That's why the power delivery topic is very important. Some technical issues also for the meeting today. We have a chat, so if you have questions later on, please use the chat to give us the questions. And we will answer this later on and discuss about it. So please use the chat. So now let's jump into the topic of today, single pair Ethernet and all the use cases what we see for single pair Ethernet in the field. And the topic of today is hybrid connectivity for single pair Ethernet with M8 and M12 connectors and something more about it. So Manuel, I'm happy to have you with us and to get the information, the latest news about this topic today.
Yeah, thank you, Matthias, for this warm introduction. Thank you to all participants here in this area and also for this topic. At first, I would say cheers with coffee because it's the digital coffee break. And yeah, I think it's a cool overview where we can talk a little bit interactive. So if you have questions of the following presentation, please directly ask or write down. I see the chat window also here. I think everybody in the home office knows that not normally is 2 or 3 or 4 monitors. You see one in my back and so on. So I would like to start with the following topic, M8 and M12 Hybrid. And what will you see in the next, I would say 35-40 minutes? You will see an overview. What can you get today of the hybrid technology? What is it for? The difference between power over data line, a short-term poodle, and also some I would say new stuff of the parts where you can put it inside the fields like an application, and also maybe I think it's the last slide, that you can bring it directly inside your application, inside your manufacturing area, and you have not to wait for a complete new machine or machine park, so you can directly implement it inside your existing machine park with the parts of the single pair Ethernet partner network, industrial partner network. And yeah, I think let's start. We have a lot of participants here. Maybe some will join a little bit later, but that's not your and our problem. So let's start with the topic. Yeah, the first slide. I think this is a typical question. The typical question is, what are hybrid systems, or what is in hybrid systems? An hybrid system calls a system where you have separate data and power applications and supply. So if you see the old one, PoE, Power over Ethernet, there you had some wires inside the cable for the power supply and also for the data transmission. And if you take a hybrid cable, there you have the same situation, but with more current and more voltages. And if you see on the left side, the power over data line, there, I think it's clear there is a big benefit behind. Lower cable weight, like the most benefit of the single pair Ethernet technology. Small form factor, yes, you have 2 wires only. I think it's clear. Direct supply means you have only these 2 wires where you have modulate the power over the data signal, and you have a closed circle. But this solution or this technology is not the solution for every application. Maybe you need more than this maximum of 2 amps. Maybe you need 600 volts, for example. You need 10 amps, 8 amps, 60 amps, like actor parts or special sensor parts. And therefore, you need a new or different technology. And this is where we are thinking that the hybrid technology could be the most benefit, could be the game changer also for single pair Ethernet in the future. You need more power for the systems. We are talking about decentralization and different trend topics in the field. And I think it's clear that the suppliers will also react to this situation and will develop some new parts, some new systems, and so on. And there you can see also the benefits and the difference to the power over Ethernet and the hybrid. So it's more especially for robotics, automation, actors, others, where you need more than these 2 amps, which are possible with the Poodle system. And also you can put there inside multiple technologies. So it's up to your application, what you need there or what you transmit there. You need in the field you have less connections. You have only 1 connector, and if you would like to use a single pair Ethernet without Poodle and need a power supply, for example, or power transmission there, then you need also a new connector. It could be an M12 power connector like KLM. It could be an standard. It could be a terminal block, and so on and so on. But it's typical, normally a new connection and also a new matting phase or a new connection interface. Maybe it's more clear. And if you use the hybrid system, then you have the 1 matting phase, 1 connector, which is possible to transmit data on the one side and power on the other side. In this case, we are talking about different matting phases areas with the M8 and M12. So there is important the form factor. Why is the form factor important? You know, one of the benefits of single pair Ethernet is the space of the connection. And this is also the reason why we started with the M8 Hybrid inside the standardization. And the expectation of the market, also market requirements are clear. We need a more robust system, and more robust as the M8 is clearly the M12. So then we can switch to the next slide. Maybe one additional note here. You can read it also in the down. Poodle and hybrid are not competitive projects or products, so they are complementary. If you need more power, use the hybrid. If you can use Poodle and you have less space in the area, then use also Poodle. There you see a typical hybrid possible architecture. What I see here in this slide, you see the possibility of point-to-point connection on the left side. You see in the middle the line topology, so that you can cross with an absolute distributor, for example, or with an T distributor. And you see the star topology. It's also possible inside the structure of single pair Ethernet hybrid systems or single pair Ethernet hybrid architectures. If you need informations about it, you can directly contact the industrial partner network, or you can also directly contact TE or your supplier, which is a participant of the industrial partner network. Yeah, what's also important here, you see the architecture also with the different nodes. I think it's clear. It's also important which current you are using in the system. At the moment, we have a lot of requests in the area of the star topology and a little bit in the line topology with these T distributors, but there I will show one slide where you can understand it a little bit better, what's available at the moment and where you can use it directly inside your application or also inside your area where you are using it. To understand what we are meaning with point-to-point, I have an example here. There you see the schematic for an point-to-point. And where we see the point-to-point connection in the future is in the decentralization module systematic in machines. You have one main machine part, and you have different, or you will have different parts around this machine. You can add something and you can also remove something. And you can add, for example, parts for cable manufacturing. You can overmold machines also on, and therefore could be the point-to-point solution if you have a directly a cabinet connection in the front. What you see here on this picture in the right, there you see a terminal with a cabinet inside. And there you will have a point-to-point connection inside the field. If we are talking about the daisy chaining or line topology, then I think it's only a picture on the right side, but the idea is clear, I think. So you have a line, you have different actors, different robots, different parts in a line, and you transmit data and also the power directly inside this line, inside this daisy chaining. And it's a topology which is actually in the field, not with single pair Ethernet, but with different other field bus systems. And I think if you think about your situation inside your manufacturing areas, you will see that you will have all of these technologies or topologies now, and the single pair Ethernet could possible for the future, but I will show it on the next slides, that you can actually change today to this technology. It's possible to add something inside your existing manufacturing areas, for example, to be a part of the IIoT. And on this slide here, I think it's clear. Power supplies and communication connection of serious systems. I think it's clear. And then here you see the next slide, the star hybrid advantage. So in this area, you have scalable applications, or you could use scalable applications. I think it's also clear. It's a little bit near the point-to-point distribution or the point-to-point connection. And it's also clear that where you need a lot of power, where there you have to use the start topology. In the next slide, you will see a little bit of the international standardization, also of the IEEE standards, and what's important. Also, what's important if you think about this hybrid system. I think it's clear an advantage of single pair Ethernet is the distance, so the possible distance or the possibility of the different distances. If you take the T1S or T1L up to 1 kilometer, 200 meters, 300 meters, and I think it's clear that this is not a use case for a hybrid system. If you need 10 amps, it's not usable or possible to transmit it over 300 meters or over 1 kilometer. There you have also on the other side the benefit of pool, because pool makes it makes the difference there. This would be possible. And if you see it inside your areas, if you think about your manufacturing area, the normal length or the maximum length inside these areas, normally to the cabinet or to the switch area or to the main application, I would say it's around of 25 meters, maybe up to 40 meters. But if we see the standard articles in the field where you have assembled cables, normally you have 10 meters, 15 meters. And this is also the field where we see this application of the hybrid system, where you need not 100, 200, 300 meters at a power application. So it's where you have 20 meters, 15 meters, or 25 meters, 30 meters to transmit power and also the data communication. And I think this is the area where we are talking in most of 90% of the areas which we know in the field. I think it's also not so possible or not so necessary to talk about unshielded and shielded cables. All of the existing systems are shielding systems. It's only for the complete information on this slide. And you see on the market, I think this is also a reason why we have a lot of participants here, the situation of the standardization. There are different committees, different standardization areas, different networks, and for you is important the situation in the field. So what can you use? What is future proof? What is also secure in the investment? And there, it's my opinion, is the international standardization very important. And you can see both of these hybrid cables, which are inside this presentation and which are inside the discussion of the market, are inside international standards. On the left side, you see the IEC 63171-6. Inside the -6 are not only an hybrid connector, there is IP20 inside, there is M8, there is M12, there is the hybrid solution. So I would say it's a complete ecosystem inside this -6 standard. And then we thought, okay, it's more usable, it's better for the market to create a new standard, a little bit out of this complete discussion, because these hybrid systems are not a competitive system in the market. These hybrid systems are standalone systems where you have an IEC standard, and this is the reason why we put it inside the -7. Inside the -7 is the complete range of the M12 solution in hybrid styles. There you have different matching phases, codings, different solution parts from 8 amps to 16 amps with different pinnings and so on. And I think it's clear that we are started this standardization. The target of closing this standard is end of this year, beginning of 2023. And at the moment, we are in the status CDE, CDV. So we closed this status and you can check the status also inside the official IEC site, and then you can put in a view inside. Maybe if you have questions, you can also directly ask the Industrial Partner Network, or contact me or my colleagues of TE. And now we go a little bit deeper inside this view of these hybrid connectors of the hybrid matting phases. And I would start with the existing M8. So the M8 hybrid is available. You can use it. Actually, you can use it directly. There you have the receptacles, the device side, you have the field side with assembled cables, and there you see only at one view the benefits of the system. But I think on the right side is better to understand how the matting phase looks like. There you see the power contacts and the data contacts. You see the power contacts are bigger for the maximum current of 8 amps. And you see the data transmission area for single pair Ethernet systems. And this standard is closed. It's an international standard. There you can put all of this information and use it for implemented inside your devices, inside your systems, for your design in. And I think it's clear this one is said. There are no discussions about this matting phases or about the technology. And then we are a little bit more open to discuss, I would say, or I said it before, it's the start of the new generation of the M12 hybrid. There you see the first 7 matting phases of the M12 single pair Ethernet hybrid. And these are the pictures or matting phases which the TE and also our partners see in the market, so which would be necessary, where we have also requirements of the market. If you see there the different types, you can see the type 1, type 2, and the type 3 are only different codings. Then you have a new application with the type 4 up to 600 volts, and then you have the type 6 and 7 for the maximum of 16 amps. And I would say it's a typical power application if you need a lot of power, for example, robotics and so on. This is the starting portfolio, the starting area of the standard. If the future, we will see in the future that more codings are necessary, that maybe also more solutions are necessary, more solutions are needed, it's not a problem to expand it. So it's directly information for you. If you see there is one important version missing, contact us, send us this request, the requirements. You can also directly comment it for inside the standardization if your company is inside the international standardization. And then we can discuss it. We can talk about solutions. I think it's clear we have to start to put single pair Ethernet in the market and not discuss about every contact, about every plastic material and so on. We have to start to implement single pair Ethernet in the field. And I think maybe we had 2-3 minutes on this slide, and everybody saw the type 2 and asked why we need an 2 8 amps matting phase. And this is not only created by TE or by the Industrial Partner Network. It's created also with customers, and we have requirements, we have requests about 2 different circuits inside this daisy chain function. So it's an concrete request which we put inside the standardization. So now you can understand how the standardization works a little bit. And there you can see how would it work. So you have two circles there, and you can put it inside one device. You can also supply two devices. It's up to you, but this is in concrete request of the market of the field. And I think it's also clear that you have different user groups which are requesting solutions, which are requesting topics and so on. And inside this area, maybe the most of you know the P&O, the Profinet Nutzer Organization. This topic is discussing there. Then you have also in a different part the discussion of systems like this in the EtherCAT area. You have also this discussion inside the ODVA, so like the American, more the North American market. And there are different requirements, different requests, which are normally included inside this standard. There are a little bit more on the side of the, or more requests, more information needed of the P&O, also more information needed of the ODVA. And at the moment, all of these companies which are involved inside the creating of this IEC standard are collecting all of this needed information, creating overviews, presentations like this one, which you see here in this area. It's at this coffee break. So cheers. And yeah, so there you have also different applications. If you see the P&O, you have it a little bit more inside the factory automation or robotics inside this area, but directly inside the factory automation. Then you have also the APL group. It's more of the process automation or inside the process automation. And then you have the ODVA. The ODVA is trying a little bit of both. So they are using some parts of the APL requirement, and they are also using some parts of the international standardization. And they are using the same structure like the P&O, where all of these producers have to show the difference between the systems, the advantages, and so on. So this is also a situation where we are at the moment, and this is also why it's so important that everybody of you know the difference between the systems, know the advantages. I think it's also clear that you have this situation on the market. And if you see why would this M12 hybrid the best solution, for example, for the ODVA or for special applications for the P&O or so on and so on and so on. There I can show you the server application. So at the moment, I think it's clear everybody talking about the digitalization, IIoT, Industry 4.0, and so on and so on. I think it's clear that these connections are completely used for this or developed for these environments, for these applications. And at the moment, you see also the change from the analog system to the digital system. At the moment, you have a lot of field-based systems which are working with signals, so in an analog functionality. And at the moment, we see, and I hope you see it also, that the market changes more to the digital environment. Maybe also inside this big data space, you need the information which are creating inside the manufacturing area, inside the office area, to use it for your production quantity, for your quality, also for the manufacturing information. And this is the big data. I would say the big data idea, to collect all of this information, which I could collect. And at the moment, I think this is also important, which I could collect at the moment. What would be necessary or interesting in the future, what is possible in the future. And this is an important point inside your thinking of what will be a part of the future inside this manufacturing. So now we have to wait to jump. Yeah. And now you see also the situation, what I mean with this decentralization. And I said it in the beginning of the presentation. It's in part, maybe we can call it a bridge technology. And why is it in bridge technology? So what is in bridge inside a new technology, or why we need in bridge? So what is important there? We are talking about decentralization. So if you have new machines, also if you have old machines, you have to put new parts inside these machine areas. You have to connect maybe new user panels for using the machines. You have to put a new robotic area inside maybe, but you have, normally it's not the normal way to remove a complete manufacturing area or complete to remove a complete machine and put a new one inside. At the moment we are talking about retrofitting, to use the existing one and put necessary new parts inside or around it. And this is one of the benefits of the single pay Ethernet Industrial Partner Network. So we have one partner inside, it's Perinet, and Perinet is a strong partner. There is a strong technology partner, and Perinet is focusing also on this topic, where we are talking about implementing single pair Ethernet in existing systems. What is also important there, what you have to think about, you have to think about the RJ45. At the moment you have, I would say 90% the RJ45 is a connecting interface inside your manufacturing area. And how to set the old ecosystem RJ45 to the new ecosystem single pair Ethernet with different matting phases, with a new technology, with a new topology, with new parts, with new sensors, and so on and so on. And there I would give you this information. Contact the single pair Ethernet Industrial Partner Network, contact directly Perinet, and ask for their solutions, ask for support to implementing these parts inside your areas. And on the left side, you can see two parts there. If you can use the old economy parts, M8 A-coded, M12 A-coded, for example, and then switch to single pair Ethernet or switch to the hybrid system. There inside you can split the power and the data line inside this hybrid, and then you can go further with one connection. You need not these two connections. For example, the M12 A-coded for power and the M8 A-coded for the signal. And there are some interesting products, some available products, so on. And to understand how it works, and also to see a little bit what you need in the future. I think this slide is important to understand. There you will have this switch to the decentralization. You need to implement this technology inside existing systems. You will have in the near future two ecosystems next to, like standard Ethernet and like a single pair Ethernet. And if you see the next slide, then I think it's more clear for you to understand how this system works, where are the benefits also, and maybe then you can also understand where you can use the single pair Ethernet inside your existing machine areas. On the right side, you see the technology on RJ45 base. Then you see the switch to the T1, so like SPE connection in IP20. And then you see the connection to the M12 to the M8 hybrid. There you see different senders. You see the T distribution, and important for you on the area of M8, these products are available. You can start to implement, you can start to test inside your physical areas, inside your manufacturing areas, maybe also inside the lab or office, to go a little bit further with this technology, to get a little bit familiar with this technology, understand it, think about where it makes sense in the field, where we could also design it inside an retrofitting project. I think it's also clear that all of you have retrofitting projects at the moment, and then you can directly think about, okay, yeah, I could put some parts of the single pair Ethernet ecosystem inside these new parts. Then I can understand how it works, and then I can work with it. Then I can also understand the difference between the existing systems, new systems, also maybe between different competitor systems. And there, I would say, contact Perinet, contact the industrial single pair Ethernet industrial partner network. It's hard to say it 3 times. Yeah, but I think I said most of these informations before. Take a look on this slide, understand it, understand that we can switch from the existing ecosystem to the new single pair Ethernet ecosystem. And yeah, I think this would be my last slide. And if Matthias is also there, or maybe he's more inside this coffee time, coffee sleep, maybe we can say
No.
coffee.
Still coffee is here. I enjoyed a little bit when I listened to your very interesting presentation and all the details about power. If you look back a little bit during the last months, single pair Ethernet as a data transmission technology was mostly in the focus. And what we all see when we are in contact with interesting people, with customers, they now start to thinking about how to bring this technology really to devices. And then definitely the topic of how to bring power to the device, especially if we go to the field, to the sensors, where a one cable solution is a must, comes more and more in focus. And I like also your comparison between Poodle as remote powering technology using the data wires in comparison with the hybrid solutions. And I guess we can a little bit go here also in detail, because what we know, there are some general questions also here to compare it. As we know, if you go with Poodle, of course you need additional controller, so special chips, or you have to implement the Poodle mechanism in microcontrollers. These are additional costs, especially today with the semiconductor topics we have all. In addition, you need also a decoupling network with filters and common mode chokes to make the decoupling of power and data. And all this are, I will say, a kind of fixed cost for your devices inside your sensors or inside the switches. And also additional space you need, especially you show up this very small M8 hybrid based devices from Perinet. You see they are very tiny. There's no space for additional filters and so on. And especially the filters, if you will transmit more power, the filters become a space requirement. Yeah, it's bigger components. And what we also very good pointed out, the majority of sensors and actuators are in a short distance below 20 meters or something like this. And when you have, at the other side, if you compare Poodle with the hybrid solution, of course, a little bit higher cost for the cable, but it's, especially if you have short distances, it's not a big issue. And we go with all the systems more or less in the real harsh environment. So we need IP65, 67 connectors. So to add 2 additional pins, for example, for the M8 hybrid is not a big issue. And so that's why also from the cost point of view, I guess hybrid is very cost effective for sensor actuator networks with short distances. And Poodle, as we also see in the market, so Poodle or similar systems adjusted to the requirements for the process industry with explosive atmospheres and so on, where we have long distances, when this fixed cost for these controllers and filter networks can be beneficial and economic, useful for longer distances. So that's why this is a point we see in the discussion with end customers and the people who really start to develop some devices. Do you see it in the same way, or what's your experiences you have already with customer discussions?
Yeah, we had directly also these informations. I show this slide again, and I hope you can see the laser pointer, but it's
yes,
a little, I have to, maybe I can paint a little bit.
See here a classical switch, going to what you are showing to the other box. This is a kind of edge computer, so they have already, so far I know from Perinet colleagues, M8 hybrid interface, and then they go all the black cables you see with the sensors on it, they go with M8 hybrid. And you see the very big advantage here, very flexible structure with this T connections. This is not only a simple T connections, they are really switches. So the power is daisy chained, but the data are switched. And by using this very tiny T switches, you can create all kinds of structures, line, tree, or whatever.
Totally right. And I think also what is important, and you said it before, you have to think in a little bit other way to the standard Ethernet. So most of the competitors of these participants are talking about the space of matting phases, of the space of devices, but we are not talking about a new RJ45 like I marked it on the right side. We are talking about a complete new ecosystem, also about a complete new system. So that I think the target is not to be a little bit smaller as an RJ45. The target is to remove all problems which we had with the RJ45 in the industrial environment. And on this slide, you can also see in the middle, I marked it there. You see, you need more space of the device. So concerning all the logical parts inside of the chipsets inside of the, it's a complete switch area inside, and the device needs more space as all of these matting phases. There you can see it. I will mark it a little bit. There you can see a free space inside this device. So it's clear that that it's also inside an electronic part. And most of this discussion about the space, I think it's not the target to be short as get so or short as possible. I think it's important to say, yeah, we are smaller and it makes sense. I think this is a very important part where you have to think about it. So the parts which you have to put inside the devices, chipsets, and so on and so on, I think it's clear that they are not in millimeter per millimeter. I think it's clear. And if you see the chipsets at the moment, and if you put inside here inside this box 4 chipsets and the complete logical parts inside and so on and so on. I think it's clear that you need this device size. And if you have the smallest connector over the world, yeah, perfect, congratulations. But is it the target? I'm not sure.
Yeah, this is all about the total cost of ownership, how it's already named in the market. Yeah, you have to look for the system cost and what you want to achieve with the system, how flexible it is and how future proven and so on. And for this, hybrid cabling, hybrid connectivity, and hybrid data and power systems are a perfect solution, yeah, for some areas. Not inside the switch cabinet, but everything what is outside in the field and what we have in mind, industrial solutions, automation and others, it's outside in the field. And for this, hybrid is really an interesting solution. And that's why we show it today to all of you who are joining us in the coffee break today, yeah.
Yeah, and I think also as an information about the requirements of the market, we started with the development of the M8 hybrid. So the M8, I think it's clear, is smaller as the M12. But the first information was it's nice that you have this small interface, but we need the M12, which is more robust, and we need this and this and this. So there you have the thinking, yeah, small, thank you, very good, but we also need it in a robust way. We also need it in a standard way, which we know in the actual or in the existing field. And then the first requirement was, what is with an M12 hybrid system? Could you use this interface also in an M12 hybrid system with this advantage and this advantage and this is disadvantage? And this is why we developed this M12 hybrid system. Market requirements, and not to be a little bit smaller. I think it's also clear that we cannot put this interface inside an M5. I'm also not sure who is working with an M5, but it would be smaller. Yes, sure, you are totally right. If you say, but M5 is smaller, yes, you are right. But makes it sense? In my opinion, no. And the requirements of the market, I think it shows that my opinion is not so bad. The requirements are develop an M12 hybrid.
Yeah, it must be always a good compromise or the best fit between size, robustness, and usability. Yeah, user friendly.
Yeah.
What I want to ask you here is there one question also in the chat about do you have plans for future hybrid solutions too? I guess with the M12 we can cover a lot of power. I guess they have in mind some bigger powers for bigger drives or servo motors and so on.
I think you said this the answer before, because if I remember the last 4 minutes or 5 minutes, you said one cable. You said something about one cable automation, one cable connection, and I can say totally yes. There are thinkings also. There are a project of the international standardization started where you have bigger hybrid solutions. I think the most of you knows the M17, M33, and so on inside this harsh environments. And totally yes, the next steps are started for bigger hybrid solutions, for different hybrid solutions. And this is why I said this is only the start of the complete ecosystem. And you said it, the magical part, one cable.
Yeah. Thanks for this details too. And I guess we have touched many aspects also of the hybrid power solutions in comparison or in combination with single pair Ethernet. Hopefully all of you get many new information, some aspects you can think about. And what you also see here, together with companies or with persons and different companies together, we work on all these topics to answer the questions coming up in the market. And as we discuss also, we all together in this network and also with customers and companies or persons are interested in technology, we build together this single pair Ethernet ecosystem. If you want to get more information, please visit our website. You see it here, single-pair-ethernet.com, where we have also section called resources, where you can find application note, technical articles, white papers. And also here we have several technical articles also about powering, also more details about hybrid. Regularly we add here more application notes. So if you have a question for a special SPE topic, don't hesitate to contact us. We will work on this and make a paper for this. Also, I want to mention, if you want to listen again this webinar today, or you want to share it with colleagues, we have a recording very soon on our website. And last but not least, I want also to point out we will have more topics very soon. So the next meeting is already scheduled for the 23rd of February about use cases and a little bit more about cabling and installation. So, and also in the next months, we will have more coffee breaks about other interesting topics. So take care for it. So you see already this is a topic of our next meeting. So you are very warm invited to all these upcoming meetings to join the network, single pair Ethernet industrial partner network, and also are interested to work on it, to found it's a very nice topic. You want to be involved deeply, you want to work together with us, please join also the network. And we will thanks from all of our sides for your time today. Hopefully you have a nice coffee and enjoy the rest of the day. And thanks for your attention.
Yeah, thank you all. Have a nice day. If you have questions, please feel free to contact us. Wish you the best and see you in the next coffee break.
Exactly. Bye-bye from us today.